A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. We shall be starting in a couple of moments. Mansi, the aphelion and perihelion question is how the aphelion and perihelion concept applies to the concept of Earth gaining velocity. Please understand, Earth gaining velocity and gaining a slingshot motion because of the gravitational pull of the sun, that provides an elliptical orbit of sorts. But whenever in an elliptical orbit, whenever you have an object moving in an elliptical orbit, there will be a position which is going to be farthest and there is going to be a position which is going to be closest. Because unlike a circle, there in the circle, all the points are equidistant from the center. So if let's suppose planet is involved in a circular orbit, then there won't be any aphelion or perihelion because all the points are equidistant from the center. And at all times, the distance will be the same. But when you have a planet moving in an elliptical orbit where the gravitational pull is impacted by the other planetary systems as well, now in that case, definitely there will be a condition where the planet will be too far away from the sun and nearest to the sun. So that is the concept of aphelion and perihelion. Okay. Biswajit, is the tilt always towards the right side? Biswajit, right side and left side depends upon the perspective. If you are viewing from this angle, it will appear to be on the right side. But what if you are viewing from this angle? Then what will you have? Right side or left side? So please don't think about it whether the tilt is to the right or the left. Suppose you are viewing from this angle. It will again appear to look like something to the right side or something towards you or against you, away from you. But if you are looking from the other side, the tilt will change, the angle will change. So it is all about perspective. From where are you taking a look into it? Which have more gravitational pull, solid, liquid, or gas? So gravitational pull is not impacted by the state of matter. Gravitational pull in itself is impacted by the size of the matter and the mass of the material. Gravitation pull is always dependent upon mass of the material and is inversely proportional to the distance between them. So heavier the object, heavier the system, greater will be the gravitational pull associated with it. Sun, for example, is consisted of only of gases, hydrogen and helium. Sun doesn't have a solid core or the solid interior. But sun is so very large as compared to Earth. Sun's mass is thousands and millions of times higher as compared to that of Earth. So sun will always have a much greater gravitational pull of attraction. Okay. Gravitational force and the gravitational pull are the same. How the Earth get that initial velocity to revolve around the sun? So please understand, it is that gravitational. I'll talk about the evolution of planet Earth also, but there has, since the time of formation of the planet, anything which has got gravitational pull, it will attract the objects towards itself. So the planet Earth, just like planet Mars, just like the planet Venus, all of them which are moving around the sun, they are moving because of the gravitational pull of the sun. Yesterday also, as I told you, now the question is that where did it get its initial velocity from, that it is not falling directly? That initially itself, when the planet's formation was happening, at that time also you had multiple objects which collided to form the planet Earth. So as the collisions would have happened, so whenever a collision happens, that provides a kind of an ample push, and that provides the velocity. So that velocity has been provided ever since the time of formation, due to the process of formation, which is the accretion model of formation, where all the materials, they were basically moving around the sun, they started colliding, forming the planets, and the planets continued that velocity gained by all the objects coming together. Okay. What is the difference between the theory of expanding universe and the Big Bang theory? The theory of expanding universe provided by Edwin Hubble, it talks about the fact, it simply noticed that all the objects are moving away from each other. So that theory tells us that the universe is expanding as we know it. When we talk about the Big Bang theory is about the origin of universe. So theory of expanding universe is about the current state, that yes, the universe is expanding. When you interpolate it, that what would have happened if the universe is expanding now? So with that, can we talk about the evolution of universe? So that evolution and formation of universe is talked about and is postulated by the Big Bang theory, that an explosion would have happened, materials would have moved apart, and that is how the entire universe would have come into existence. Okay. What is the difference between the terrestrial planets and the Jovian planets? So basically, one of the terrestrial planets are present closer to the sun. They are smaller in size. The Jovian planets, or the gas giants, they are much larger in size, greater gravitational pull of attraction. The temperature is lower as you move away from the region of the sun. Then also there, because of their size, their orbits will also be different. Many of them, the rotation time taken is much lesser. So these are the basic differences. Vishwas, how much distance covered by Earth within 1 minute? Okay. So you are talking about the distance. So think about it. Over a period of time, the planet Earth, you can always have a derivation of it, that on an average, if you extrapolate the planet's orbit around a circular path with a radius of 150 million kilometer, the time taken you have, the distance you have, accordingly you can interpolate the calculation about it. Expansion means increase in size. Okay. So now we move forward with the aspect of seasons of Earth, in the sense that here we are going to talk about that why is it that planet Earth experiences the existence of varying different seasons. And this has got to do with the rotation of planet Earth on a tilted axis. When the planet Earth rotates on a tilted axis, basically that brings into play the fact that different parts of the planet, they have different level of exposure to the solar rays. And that means certain areas will get greater exposure to the solar rays, and certain areas will get lesser exposure to the solar rays. Now, when in any region, when you have a greater exposure and for a longer duration of the day, you get the solar rays or the solar insolation, obviously you will experience summer season. And when any region receives lesser duration of the solar insolation, that region will experience winter season. For example, even from your day-to-day experience, you can always count about the fact that during the summer season, during the summertime, the duration or the length of the day, that is going to be much larger. During the winter season, you would have observed that the duration of day is smaller, nights are longer, isn't it? So when days are shorter, means heat is received for a lesser point of time, lesser amount of time. And whenever days are longer, that means heat is received for a greater period of time. So that ends up, when you have a variation in the amount of heat received, that brings about into existence the various different seasons, the different duration of day and night. That is also brought about due to the tilt of planet Earth on its axis. So here let us observe, why is it and where is it that across its entirety of orbit as it moves, the planet experiences different seasons. So here, if you take a look at it, we will observe this planet. Now, this is, let's suppose, the region of equator. This is the region of equator. Okay. Here you have the region of equator. Now, the planet moves in a kind of an anti-clockwise direction around the sun. Now, the equator basically ends up dividing the planet into northern hemisphere as well as southern hemisphere. Here also northern hemisphere and southern hemisphere. So, if you first of all observe the situation around December, around this point of time, now you will observe that it is the southern hemisphere which appears to be tilted towards the sun, right? So here, observe the circle of illumination as well. This is the circle of illumination. Observe this. That means the region to the other side of it, they will be experiencing night, and the region on the brighter side of it, they will be experiencing daytime, right? That is what the circle of illumination indicates to us. Now, once we know that, here, observe that when we talk about northern hemisphere, just notice the northern hemisphere from this figure. When we observe the northern hemisphere, basically, a very small portion of northern hemisphere is lighted by the sun. And for a majority part during the entire rotation of the planet from west to east, a majority part will be hidden from the sun. So that in itself indicates a longer night and a shorter day. Because for a lesser period of time during the day, the planet will be exposed to the sun, especially the northern hemisphere. So that means you will have longer nights and shorter day in the northern hemisphere in this position. And when we talk about the southern hemisphere, majority of the southern hemisphere appears to be tilted towards the sun, is facing the sun. And that is why it will experience longer days and very short duration of the nights as well. So let us take a look at what the various seasons basically they pertain to when it comes to the position of the planet Earth. And also, we'll take a look accordingly at the different seasons which we experience and the conditions thereby. So starting with the month of November, December, January, February, right from the month of October onwards. So during this entire duration from October all the way till February, you will find a condition where the planet is positioned in this particular situation, where here I hope we all can figure out the circle of illumination. It distinguishes the difference between day and night, the part of the planet which experiences daytime and the part of the planet which experiences nighttime. And here you will have the presence of equator. This is the region of equator. So obviously, this will be your northern hemisphere. This will be your southern hemisphere. So again, if you will notice, a majority of the portion of southern hemisphere is always exposed to solar rays, whereas that is not the case in the northern hemisphere. So during these months, in the northern hemisphere, what will you experience? Shorter days and longer nights. Isn't it? Shorter days and longer nights. Shorter days means what? It will receive heat for a less duration, less number of hours it will receive heat. And during night time, it becomes colder because the land loses heat, etc. So there will be a shorter duration during which heat is received and a longer duration during which the heat is lost. So this will be the condition of winter season. Very good. This will be your winter season. So during these months in the northern hemisphere, you will experience a very significant winter season to exist. But what about the southern hemisphere? In southern hemisphere, it will be exactly the opposite of what is the situation in the northern hemisphere. In the southern hemisphere, you will observe that for a greater duration, there will be daytime, and lesser duration during the day, you will experience nighttime. So you will have longer days, good, longer days and shorter nights. And this brings about in existence summer season. Right? So sunrise will happen earlier, sunset will happen at a later point of time. And here also in winter season, you would have experienced that sunset happens a lot earlier, right? It becomes dark very early, right? And then the sunrise time is also delayed. Whereas during the summer months, you would have observed that the sunrise happens quite early and the sunset also happens quite late. So duration of day and night, that ends up getting varied. So that is what you experience here. Now, by the way, when we talk about the region of the Arctic and the Antarctic region, that is the polar region, during these months, what do you observe? Observe this region of Arctic Circle. This is your Arctic Circle. And here you will have your Antarctic Circle or the South Pole. South Pole. Here you have North Pole. Now, if you observe the region of North Pole and the region around Arctic Circle, you will observe that regardless of how many rotations the planet takes under this position, it will always be hidden in darkness, isn't it? It will always be hidden in darkness because the solar rays will never manage to reach there. The solar rays will never manage to reach there, right? So, North Pole and the Arctic Circle during this time will observe permanent darkness, a night which continues for almost 4 to 5 months. Sun never rises above the horizon in this case. By the way, horizon, what is horizon? So when you observe the sunset and the sunrise on your day-to-day basis, you would observe that the sun appears to rise up in the sky, right? So that imaginary point where it appears as if the sky meets the ground or sky meets the surface, that is the horizon, where you observe the sun to be rising up. And then even during the sunset, you will observe that the sun basically starts hiding and eventually completely sets. That is the horizon. So during these months, you will observe that basically during the months of October all the way till February, so during these months, you will observe that northern hemisphere experiences summer, southern hemisphere experiences winter. Other than that, you will also be observing that in the polar region, here in the region of Arctic Circle and North Pole, right, this is opposite. Good. So in the Arctic Circle and North Pole, you will observe perpetual darkness, right? Prolonged nighttime. Night for many months. The sun does not rise above the horizon. Does not rise. above the horizon. Whereas in the region of South Pole and Antarctic Circle, there will be something quite the opposite. Antarctic Circle. So in this region, observe in this position, regardless of how many rotations the planet makes, the Antarctic region and the South Pole will always be exposed to solar rays. So this is the region around South Pole and the Antarctic Circle, which will perpetually experience daytime. And when you think about daytime, please don't compare it to the daytime that you experience in India. Because here, during the day, what do we experience? That the sun is vertically overhead almost during 12 noon, 1 p.m., 2 p.m. You will observe that the solar position is almost vertical above the ground surface. That is when we receive so much amount of heat. But when we are talking about here, that there is perpetual presence of the sun, observe that the solar rays will be very tilted when they reach there. So it will not be as if the sun has risen right up till the top, just like what you observe during early morning or late in the evening, where the sun is at a position close to the ground. So that will be the condition always, where it will not give you substantial amount of heat, but it will be continuous light, continuous daytime. So in this region, you will have continuous daytime. Continuous daytime. The sun does not set below the horizon. Does not set below the horizon. Okay, so that is why you will observe, if let's suppose the planet had not been tilted, if the planet would have been, let's suppose, as it is without any tilt, now in that case, what would have happened? Obviously, one would be intrigued to find that out. So think about a situation where, let's suppose, I draw the planet like this, right? And this is an imaginary case, so don't get confused. But you said that there was a tilt, now you are saying it is not tilted. So it is not like that, it is just an imaginary situation. I'm painting a picture in front of you, that what would be the situation if, let's suppose, the planet had not been tilted. If, let's suppose, here is the sun. Now as the solar rays, they fall upon the various different parts of the planet, you would observe that in this case, both the hemispheres would receive equal amount of solar rays. It wouldn't be the case that northern hemisphere is receiving more heat or lesser heat, and the southern hemisphere is receiving more heat or lesser heat. Both of the regions would receive equal amount of solar rays. That means what? Duration of daytime and nighttime will also be similar, because as the planet would rotate, the circle of illumination would be somewhere here. So the duration of daytime and nighttime would also be equal. So that is why, if there would have been no tilt, then there would not have been any seasonal variation, any variation in the length of day or night. It is because of Earth's tilt and the Earth's motion around the tilted axis that different regions experience different duration of day and night, and thereby the presence of the different seasons also. Now, this is the condition in the month of December. Now, even if, let's suppose, the planet, let's suppose, is situated here, or let's suppose it is situated here. In any of these cases, if you were to build the orbit or the axis of it, here also, if let's suppose you were to build the imaginary axis of it, now in both the cases, you would observe that the similar situation would have happened, that it is the southern hemisphere which gets more solar rays. Northern hemisphere appears to be tilted. Right. So the duration of day and night would have changed. It is the maxima of this position which is experienced around 21st, 22nd of December. What do I mean by that? So forget everything else. Compare your memories from the summer season to now. In the summer season, you would have experienced that the daytime is much longer, the night time is much shorter. right? Every day you would have been experiencing, as we enter into the month of November and as we progress towards the month of November, you would observe that the night time keeps on getting longer and longer. Not on a daily basis by 1 hour, but ever so slowly. The daytime keeps on getting shorter and shorter, and nighttime keeps on getting longer and longer. This will continue to happen till the planet reaches this position, right? That is the position of solstice. And here, what do you observe is under those conditions, that happens on around 21st or 22nd of December. That is what is winter solstice or December solstice. Solstice or winter solstice. So during this period of time, you would basically observe that the northern hemisphere, that all of us, we will experience the longest duration of night and the duration of the day will be the shortest. Whereas in the southern hemisphere, the duration of daytime will be the longest, duration of nighttime will be the shortest. So that happens around, let's say, 21st of December, northern hemisphere, longest night and shortest day. Whereas in the southern hemisphere, you will observe longest day and shortest night. Okay? So that is how, as the planet moves around the orbit of the sun, not every place will have the same level of exposure. Let's suppose the planet here, if I remove some amount of debris from the image, let's suppose the planet is in this position. Here also, northern hemisphere will will experience shorter length of the day. But here, the length of the day experienced here and the length of the day experienced here, will they be the same? Obviously not. The length of day that you experience during the month of November and the length of day that you experience during the month of December, are they the same? Absolutely not. Right? The day length keeps on getting shorter as you move towards the month of December. And again, as you move in the month of January, February, etc., there again, you will find greater solar amount of solar rays falling upon the northern hemisphere also because of the position of the planet Earth, and the length duration of the day starts to ever so slightly increase. Right? Then eventually the planet comes by the month of March, around 21st to 23rd of March. The planet comes in this position. Now here, in this position, if you will observe, here, is the northern hemisphere tilted towards the sun or the southern hemisphere? The answer is neither of them. Both of them appear to be equidistant. Why? The tilt is still present. But here, if you can imagine it, let's suppose this is the position of the sun. This is the tilt. I hope you can see this. This is the tilt. So in this position of tilt, here the southern hemisphere will experience greater rays of the sun, northern hemisphere will receive lesser rays of the sun. Now when the planet comes into this position in front, now here, neither is the northern hemisphere tilted towards the sun nor is the southern hemisphere tilted towards the sun. They are tilted in another dimension altogether. But when they are in this position, that means both the northern and the southern hemisphere will end up receiving equal rays of the sun. And that basically means that is a condition during the month of March where you observe that the tilt is there, but it is in a different direction altogether. So here you will observe that equal amount of solar rays, they fall in both the hemispheres. Right? So this situation is experienced both during the month of March and also again as the planet completes its movement and again during the month of September. So when you have both the hemispheres experiencing equal duration or equal amount of solar rays, and also as you will observe, this is the axis, right? And this will also be the circle of illumination here. So that means duration of day and night in both these cases is going to be the same, right? Because for equal duration, one portion will be hidden behind the circle of illumination, and for equal portion, that region will receive sunlight also. So here you will observe that the conditions of equinox prevail. Conditions of equinox, that prevails. Here you will experience basically presence of, or both in the northern and the southern hemisphere, southern hemisphere, equal amount of solar rays, and that means equal duration of day and night, right? Equal duration of length of day and night. That is why equinox, because you have equal duration of day length and night length. Now this is experienced when? In the month of March, right? Around 21st to 23rd of March, and then again in the month of September, around 23rd of September, you will observe these equinox. Okay, so equinox basically means equal length of day and night. Now catch the trend here. Okay, analyze very so briefly, disentangle yourself from the normal doubts and issues that you have been having, that why it rotates, etc., etc. Think slightly beyond the aspect. Now, if you take a look at the planet's movement in its orbit, in its entire pathway, observe, first of all, in the month of September, duration of length and duration of day and duration of night in this case is equal. That is almost 12-hour day, 12-hour night. Then, as it reaches here, December solstice represents the shortest day and longest night. So that means in its motion from here to here, the length of the day keeps on reducing for the northern hemisphere. Length of the day keeps on increasing for the southern hemisphere, isn't it? Because the tilt gets exposed to the side angle of the solar rays. Again, from this position all the way to the position of March. In March, again, equal day and equal night. So again, the length of the day keeps on increasing here, isn't it? Now, this length of day after the season of March, this continues to increase in the northern hemisphere furthermore. Now, by the time that you reach the position demarcated here, you experience the summer season in the northern hemisphere. This is the position that you will experience for the months of April all the way till the time of August. Because September, again, you will experience equinox. Now, in this position, look at the circle of illumination. This is your circle of illumination. This is your North Pole. This is your South Pole. This is the region of your equator. So here, northern hemisphere gets a greater exposure to solar rays. Southern hemisphere gets lesser exposure to solar rays. isn't it? So here in the northern hemisphere, you will experience what? Length of day, or simply rather than that, longer days and shorter nights, and shorter nights. Whereas that will be the summer season. Whereas in the southern hemisphere, it will be exactly the opposite. Here in the southern hemisphere, you will experience shorter days and longer nights, isn't it? So that means it will be winter. So when it is summer in the northern hemisphere, it is going to be winter in the southern hemisphere. And when it is going to be winter in the northern hemisphere, it is going to be summer in the southern hemisphere. Now that is the condition which persists and pertains during these months from April to August. Now what about the region of the North Pole and the region around the Arctic? So when we talk about the months between April to August, here, April to August, here you will observe what happens in the month or in the region around Arctic and North Pole. What happens there? Observe the position here. This is the region around Arctic Circle. This is the region which we regard as North Pole here. Okay. So regardless of how many rotations the planet takes in this position, you will always find that the Arctic is lit up. Always it will be receiving solar rays, and so will the North Pole also. So here we can say that during these months, you will never experience the sun to set below the horizon. You will consistently experience daytime. So here you will have consistent, constant daytime as the sun does not set below the horizon. Okay. Those of you who are still getting confused by the term horizon, I hope everybody understands the term horizon by now, isn't it? Good? Okay. No. Okay. So, see, horizon concept you would have drawn from your childhood days, when you would have drawn various different images and various different rudimentary drawings like this, rivers moving here, a mountain happening here and there, existing here and there. You would have always drawn a rising sun like this, right? All of you, I'm sure, during your childhood days would have drawn this rudimentary image that the sun then continues to climb up, right? So this is basically the point where the sun appears to rise up. That is what is referred to as horizon. Okay, that is what is regarded as horizon. So even on your day-to-day basis, when you observe the sunset, when do you say that the sun has set? When the sun is not visible anymore? I hope by this time in your life you would have experienced the rising sun and the setting sun sometime or the other in your life. You would have seen that, okay, the sun is rising. So where is the sun rising from? Sun, is it straight away appearing in the sky? All of a sudden, the sun god brings about some amount of heat, some amount of glamour, and suddenly the sun is up there in the sky. No, you observe the sun to be rising up from it and if you have to demarcate where the sun is rising from, you would always think about, okay, far away in the distance it appears that the land and the sky is meeting, so from there the sun is rising up. You would all have drawn this image. You would all have drawn this image that the sun is rising up, and eventually the sun will grow bigger and bigger, and eventually the sun has risen up, isn't it? So this imaginary place where the sun and the ground appears to meet, they never do meet, but where they appear to meet, that is referred to as horizon. Understood? Right? Good. Are you saying horizon or horizon? As in the pronunciation of it is horizon. Okay. So I hope that is why it is said that sun never sets on the British Empire. Okay. Beautiful. That is because British Empire over the during that duration, during the 1800s, had its expanse across the globe in such a way that at every point of time some or the other region would be experiencing daytime, which would be under British Empire. So that is why it would be said that the sun never sets on the British Empire. Yeah, this is a history question, but nonetheless. So here, that is basically what is experienced during the in the region of North Pole and the region of the Arctic, where consistent daytime. And if you have to imagine what a consistent daytime would look like, again I would say, don't compare it with what we experience in India. India is very hot tropical country, so that is why here the solar presence is always roughly vertically above us, heating the ground surface, providing substantial amount of heat. But remember, the position of the sun that you experience early in the morning or late in the evening, you will experience that it has not exactly set below the horizon, but it is present somewhere, not very powerful. So that is a feature or a phenomena that you will experience here. Okay, so that is why consistent daytime. Whereas in the region around Antarctica, in the region around Antarctica and the region around South Pole, here the Antarctic Circle, you will experience that regardless of how many rotations happen, this region will never experience daytime because the solar rays are unable to reach this. So in the region of Antarctica and South Pole, constant night. That is why whenever you will observe Antarctic expeditions being carried on, various different countries they carry out expeditions to Antarctica. India also has got its scientific basis established in Antarctica. Now, whenever that expedition to Antarctica goes or comes into existence, it will always be during the Antarctic day. During the Antarctic night time, everything shuts down because for that prolonged duration of continuous night for almost 6 months, you will have no solar rays. So obviously, you can think that the temperature plummets to somewhere around minus 55, minus 60 degrees Celsius in Antarctica. So obviously, not the working condition. It is during these months, that is during the months of October, November, etc., that you will find maximum expeditionary missions going to Antarctica from the region around New Zealand, from region around Argentina, from these areas. All the expeditions during these months, they will go to Antarctica because right now Antarctica is going to experience consistent daytime for the next 2 to 3 months more. Okay, so here again you will observe that basically the position of, or this position is exploited to the maximum in the sense that this position is going to be apparent to the maximum tilt exposed to the sun during the time of 21st of June, what is referred to as June solstice or the summer solstice in northern hemisphere. So June solstice or summer solstice. which is experienced around 21st of June. Here you will have longest day, longest day, and shortest night. In the southern hemisphere, you will experience shortest day and longest night. Okay, that is the reason why. Suppose the planet, let's assume the planet would not have been tilted. So throughout the year, it would have experienced equal length of day and night. Throughout the year, you would have the same climatic conditions experienced, right? Because equal length of day and night means equal amount of heating throughout the year. But right now, what do we have? What do we experience? Because whenever the planet's position is such that the northern hemisphere appears to be tilted towards the sun, that is the condition of summer in the northern hemisphere. Whenever the condition is such that the southern hemisphere is tilted towards the sun, it will be summer in southern hemisphere, and vice versa conditions in the other hemisphere also. So that tilt, movement of planet Earth on the tilted axis, is the reason why we experience variation in the length of day and night also. This was a question which was asked in the prelims examination once, that what is the reason or the causation for the variation in the duration of day and night. Okay, now after this we will cover the basics of longitudes and latitudes. Even though you would be aware about what they are, you would have heard about longitude and latitude. What they are basically imaginary lines drawn across the planet. Now, earlier it was the longitude, earlier it was the latitude which came into existence. Now, latitudes basically they are also referred to as the parallel circles across the planet Earth. Because this is the latitude, you will observe they basically each one of them are parallel to each other, right? They will never meet, these lines will never meet. So what is the purpose of having these imaginary circles? So long time back, around hundreds of years back, when mariners and sailors had to navigate from one region to another, that point of time you did not have Google Maps, right? I'm sure many of you would not know, you would have been born at such a point of time. You would never be even aware that a world existed without Google Maps. So it would be hard for you to imagine that, yes, indeed, there was a world without Google Maps. But think about 200, 300 years back, 400, 500 years back. No Google Map, no particular technology at hand. So how would the sailors navigate? They would always navigate or move from one place to another with the help of the position of the stars. The stars would give them the direction, and the stars would point to certain direction, and accordingly they would keep their position. Now, in order to aid those particular navigators, that where you are moving, in which region you are, you had the devising of these parallel imaginary lines, which were referred to as latitudes, right? These latitudes give a location across any part of the planet. And the largest circle of parallel which is drawn here will obviously be the one which is drawn closer to the center. And this is what is equator. Equator accordingly divides the entire planet into two hemispheres. Hemisphere means half sphere. So equator divides the planet into northern and the southern hemisphere. Now here, when we talk about longitude, why is it that the longitudes came into existence? What was the purpose of them? So these are also circles, by the way, but they are not parallel to each other. They intersect each other at the region of the North Pole and the South Pole. They always intersect and crisscross each other. Now, here, longitudes came into existence because of the difficulty in timekeeping which was being faced up. For example, let's suppose Earlier, now we have a kind of a unified time system or a kind of an international time system. But then, if you think about maybe 200 years back, if somebody would have told you that this incident happened at 5 p.m. in India, now 5 p.m. for 5 p.m. in Indian time, 5 p.m. in British time, 5 p.m. where? Because when it would be 5 p.m. in India, it would be very different time condition in Britain. It would be very different time condition in Americas. So there was a need to have a reference time. What should be the reference time around which the entire world can adjust their watches and around which the entire world can basically keep track of the time experienced in each of these areas? So, for that purpose, longitudes were brought into existence. Now, these are all circles. Now, circles mean what? That they will crisscross the entire planet. So, half of the longitude, that is the one which joins the North and the South Pole, because the entire circle passes through North and South Pole. If you divide the circle into two, you will have half of these longitudes joining North and South Pole. So, half of the longitude joining the North and the South Pole, they are referred to as meridians. It was decided in the 1800s by the Postmaster General of London. Postmaster General of London at that point of time, during the colonial times, was as powerful a position as it could be because it was the height of the British Empire. Now, Postmaster General of London, who was also in charge of keeping track of time across, now he decided that the meridian which passes through the Royal Observatory of Great Britain, that should be considered as the point of reference or the 0 degree meridian. And along that, according to that, all the other meridians would be named thereby. So, what was done? Basically, if you think about this as the planet, if you think about this as the planet, suppose we are taking a view from top, we are taking a top view. Now, if you take a top view, you will observe that all these longitudes, they appear to crisscross each other. These are all circles. These are all your imaginary circles. Now, let's suppose one of them, you consider the one passing through the Royal Observatory, which is present near Greenwich in London, near London, that you have chosen as the reference or the 0 degree. So, this is your 0 degree meridian. This is also what is referred to as the prime meridian. Prime meridian. Meridian is what? So, the half of a longitude. Longitude is the entire circle that you draw, the entirety of this circle that you draw. Now, this circle, the entirety of it, even the other side of it. But the half of it that you consider, that is meridian. So, 0 degree is the prime meridian. The exact opposite of it will be how many degrees? This one will represent how many degrees? 180 degrees. Perfect. So here, this will be 180 degrees. Right? So this is the prime meridian. This is referred to as anti-meridian, exact opposite of it. Anti-meridian. So overall, you'll find that even this prime meridian and the anti-meridian, the entire longitude of it, that divides the planet into two hemispheres here also. You have the one to the east of it, referred to as the eastern hemisphere, the one to the west of it, referred to as the western hemisphere. Okay, so the entire planet also is divided by the longitudes in two hemispheres, by latitude also into two hemispheres. Okay, now accordingly, these longitudes help us understand the duration, or basically the reference time and the standard time followed in each area. We will come to that. But before that, let us talk a bit about these latitudes. What are latitudes? Latitudes are imaginary circles parallel to the equator. On the map where the north is up, latitudes run laterally from left to right. Okay, but how do you name these latitudes? You will find that the latitudes are named 10 degree north, 20 degree south, 40 degree north, 50 degree south. How is that naming arrived at? So if you have to name any particular latitude, let's suppose if you have this as the planet, let's suppose, and you have to name this particular latitude, that which is this latitude, how will you find that out? Whether it is 10 degree, 20 degree, 30 degree, 40 degree, how do you find that out? So what is done? Let's suppose this P represents the position of the latitude that I want to be named, right? And this is your equator. Q represents your equator. This is your Q, this is your P. Now, if I want to measure the angle of the latitude, what I do, I join an imaginary line from Q to the center of the planet, and I join it with P. Okay, so from Q to the center, imagined center, I join an imaginary line here. And again, I join an imaginary line from the latitude that I want to name. So there, I measure the angle made between these lines. Let's suppose the angle made between these lines comes out to be 40 degrees. Let's suppose. Now, because this is situated to the north of equator in the northern hemisphere, this will be named as 40 degree north. Similarly, let's suppose I have to name a latitude which is present here, this one. Let's suppose. Now, what do? I follow a similar process. I join this with the imagined center of planet Earth. Let's suppose this comes out to be 30 degrees. It is to the south of equator, so this will be 30 degree south. Isn't it? So that is how you go for the naming of these latitudes. The numbering of these latitudes is done on this particular basis. Okay, so here you will observe that this is the region of equator, which is considered to be the reference latitude, that is 0 degree. Okay, all around it you will find that in the northern hemisphere 23 and a half degree north is referred to as Tropic of Cancer, 23 and a half degrees south is referred to as Tropic of Capricorn, 66 and a half degrees north is referred to as Arctic Circle, 66 and a half degrees south is referred to as Antarctic Circle. The poles, they represent 90 degrees. North pole at 90 degree north, south pole at 90 degree south. Okay, but this is something that you would have read in your very elementary level of schooling. So reference line is equator. Yes, reference line is equator in this case. Okay, Dinesh, I'll come to it, don't worry. So that is the case of latitudes. So here, how are they named? They are named after the angle created by a line connecting the latitude, whichever latitude you want to name, and the center of the earth. And the line connecting equator and the center of the earth, whatever angle you arrive at, that is how, or that is what you will name the latitude as. Okay, right? Is this portion understood till now? Good. So what will be the total number of latitudes? You cannot have, if each latitude represents 1 degrees, then see, latitude, even 23 and a half will have a latitude, even 24 and a half will have a latitude. So whenever you talk about a latitude, so if assuming each one of them represents 1 degrees, you will have 90 of them in one hemisphere, 90 of them in other hemisphere, equator added on. So close to around 181 you will have. But North Pole and South Pole, they are points rather than circles. So if you eliminate them, you will come at 178 or 179. Okay. Kuraku, how can I tell a position of the Earth in degrees of latitude? So, any position there, for example, in India, you want to find out what is the location or position of Madhya Pradesh. So, you will find out that Madhya Pradesh is situated around Tropic of Cancer, around roughly 23.5 degree north. But whether it is positioned at east or west, so on 23.5 degree north, you will have many places across the planet on 23.5 degree north, right? How do you pinpoint to the exact place? For that, you need the help of longitudes. So the longitudes, basically, they are geographical positioning markers that run from geographical north to the south pole, intersecting at the region at equator, right? They meet at both the poles and specify the east-west position of any location. Now here, you will observe that basically even these longitudes, they have the presence of meridians, half of it, that are referred to as meridians. Now, the meridian passing through the Royal Observatory in Greenwich near London, that has been chosen to be the prime meridian. That is the reference point, 0 degree. So that has been marked as 0 degree. Prime meridian is marked as 0 degree. Okay. Now, just like equator was marked as 0 degree, all the other places were named accordingly. Here also, all the other meridians are named accordingly. So, if you think about it, how do you name a particular longitude? A similar process, a similar fundamental as you would experience in the situation earlier with the naming of the latitudes also. Here also something similar will be experienced. Let's suppose you have to name this longitude in particular. Okay. Now here, you will follow the same process. You will join this with the imagined center of the planet Earth, and you will join a line to the prime meridian. Now thereby, you will find the angle. Let's suppose this angle created is 120 degrees. It is to the west of prime meridian. So this will be named as 120-degree west longitude. Okay. Accordingly, you will name all of them. So for example, when we consider the planet, again, if you view the planet from or have a view in the top view portion, if you are taking a look at the planet from top, let's suppose here. Now, in that case, do the same thing. Demarcate this longitude. Okay. All of them here, they are intersecting because you're taking a look at the from the top. All of them are intersecting at the region of the North Pole, isn't it? So let's suppose we consider this to be the prime meridian, that is 0 degree. This will be 90 degree, right? This will be how much? 180 degree, isn't it? Now, this is your prime meridian. Okay. Now, if I want to name this particular meridian or this particular longitude out there, what will I do? I will measure the angle that it makes with the prime meridian. Let's suppose it makes 150 degree. So it will be 150 degree to the east of prime meridian. So east, 90 degree east. If I have to measure this particular longitude, let's suppose it ends up making, let's assume, 70 degrees, right? Let's suppose this is your 70 degree. So I'll name it 70 degree, but I will name it west because it is situated to the west of prime meridian. Similarly, this will be 90 degree west, right? And 180 degree will be as it is. So in total, you will find that for each angle also, you will find a respected longitude in existence, a relevant longitude in existence. So basically, the prime meridian is set as 0 degree longitude and it divides the planet Earth into eastern and the western hemispheres. Okay, all the other longitudes are basically measured and named after the angle they make with respect to the center of Earth from the intersection of the meridian and the equator. That is, you join an imaginary line from the meridian to the center, right? And the longitude that you want to measure with the center, you find that angle. Let's assume this angle is 120, 130, 140, whatever that angle is, it will be named accordingly. Okay, so that is why basically you will observe that, or that is how basically you have the longitudes, and that is one of the things which helps us keep track of time also. Prime meridian is considered to be the international reference time. Okay, it is also what is referred to as GMT, that is Greenwich Mean Time. Okay, that is your reference time. When we talk about India, Indian Standard Time, you would have heard about Indian Standard Time also. So Indian Standard Time with reference to GMT is GMT plus 5.5 hours. So that means in India, we experience that the time is 5.5 hours ahead of what you would experience in Greenwich. So suppose right now the time in India is 7 a.m. So what would be the time in Greenwich as of now? Would you think? Very good. No. Okay. Majority of you are correct. It would be roughly around 1:30 a.m. Isn't it? It would be 1:30 a.m. because we are ahead in terms of time. Why are we ahead? Because the planet rotates from west to east, right? So India will experience sunrise much earlier as compared to the region in Britain, the region in Europe, the region in Americas. We will experience daytime or sunrise much earlier, right? Japan is even further ahead than us. So in Japan right now, it would be the condition of noon, whereas in India, we have early morning. In the region around UK, you would still have night conditions. When you go further to the region of US, that is the region which would be experiencing evening. Okay, so that is how relevant time and reference time period is maintained. Now here, each of these longitudes, each of these areas, they give a reference of the time which is observed there with reference to the GMT, the Greenwich Mean Time. By the way, the concept of GMT, etc., is it something not taught in school nowadays? Most of you would have read it in school, isn't it? Anybody who is hearing these terms for the first time in their life? Anybody hearing longitudes and latitudes for the first time in their life? Okay. Okay, fair enough. Even if you are hearing it for the first time, I hope that this will settle in, this will sink in with the passage of time. As you get more familiarized with the planet Earth, as you get more familiarized with the mapping concepts, etc., this will settle in and sink in. Allow it to sink in. Okay, so here now we come to the portion of international dateline. What is that concept of a dateline? So here, think about it. Observe this image. I hope this image is clear to you. Now, if you observe this image, this represents, the red line represents the prime meridian. Okay, this represents your prime meridian. Now here, this is India's position. So India basically observes the time here 5.5 hours ahead of it. Now, just like that, if you experience here in the region to the east of Russia, here, what is the time? Plus 12. GMT plus 12. So let's name this place as A. Simultaneously, let's do one thing. Let's name this position in the region of Alaska as the region B. So if At GMT, we have seen what is the time at GMT? 1:30 a.m. Isn't it? So what will be the time at position A? A is GMT plus 12. So what do you think will be the time at A? 1:30 p.m. Isn't it? This will be your 1:30 p.m. Okay. What about this position? B. B is GMT minus 11. Okay. So GMT is 1:30 a.m. as of now. So what will be the time at B here? Around the eastern portion or western portion of Alaska. What will be the time? Here, very good. Gongala, basically, each of these longitudes, they represent a reference time point, reference with respect to GMT. That is how we calculate. It is going to be 2:30 p.m. 2:30 p.m. in the afternoon. So near Russia or Japan, it is around 1:30 p.m. in the afternoon. Near Alaska, it is going to be 2:30 p.m. in the afternoon. But then, all of them on the same day? No. A is basically experiencing, as of now, it is going to experience 9th of November. A is experiencing 9th of November. Isn't it? We all are experiencing 9th of November. But what about B? At 2:30 p.m. in the afternoon, basically, B will still be experiencing 8th of November itself. 8th of November. Ayushi, sir, I am confusing. Don't confuse. Look at the concept. Concept is not confusing, even if you are. Concept is very simple here. Concept is basically about, so wait for the entirety of the portion to be completed, and then you will understand it. What is it that is simply bouncing over your head? By the way, this is not exactly geography that we have not yet started till now. Okay, what is it that is very confusing? Anu, please tell me. Timing. Timing of what? Please tell this topic again. The entire topic? Should we start again from the seasons of the planet? How it is 8th of November at B. Okay. For a brief moment, think about it as if you know the map of the world. Think about it that this is the region of United States. I hope we are aware where United States and North America is. Now the planet rotates from west to east. Continuously, the planet rotates from west to east. Okay, let me take you back a few slides here. Okay. If I take you back to this particular slide here, the planet is rotating from a direction of west to east. Presently, you are able to see the region of North America. So this is a region which is experiencing nighttime as of now, isn't it? But it is moving towards the lighted portion. So maybe late at night, 2 a.m., 3 a.m. at night, it would be experiencing. Very soon, it will experience daytime, isn't it? India, let's suppose, is on the opposite side of it. India might be experiencing 3 p.m., 4 p.m. in the afternoon, right? And it would be experiencing nighttime. So the planet overall is a sphere. It rotates. So one portion which experiences daytime, opposite portion of it might be experiencing nighttime also. Okay. So that is where the concept of date comes into existence, that which date will you follow. So right now in India, we are experiencing which particular date? What is the date presently? Now, 9th of November. But 9th of November started when? Only around 7.5 hours back. That is when we had 9th of November. Before that, it was 8th of November. I hope that is clear. Right now, it is 9th of November. But before that, it was 8th of November. Right. So we have entered into 9th of November. But what about the region of US? If I consider the region of US, will it also be experiencing 9th of November? No. That position would not have come in front of the sun till now. Right. So that region would be experiencing 8th of November itself. But at 8th of November, which time? Right. So somewhere around the afternoon, the daytime is what they would be experiencing. So basically, the region of Japan is also experiencing daytime as of now. Why? Because the region of Japan has experienced sunrise lot earlier. So it is also experiencing daytime. And US is also experiencing daytime. But there's a difference in date, isn't it? Japan is already experiencing 9th of November because the sun has risen up. US is still in the 8th of November because there even nighttime has not occurred till now. At least in the west coast of US, nighttime would not have occurred till now. It would still be lighted up. So that is where you will experience that one portion is experiencing daytime, as is the other portion, but both of them are experiencing different days altogether. So that is where you have the exact opposite of prime meridian, that is around the region of anti-meridian. A line is drawn which is zigzag in nature, which is not straight, that demarcates the difference between one day to the next. And that is what is referred to as international date line. Why it is zigzag, we will come to it. But this line, which demarcates the difference from one day to another, that is what is referred to as international date line. So IDL is an imaginary line on Earth's surface defining the boundary between one day and the next. Okay. Now, as you cross international date line from one portion to another, you will experience some differences. I'll come to it. So date line is not straight. Why? The date line runs from North Pole to South Pole and marks the divide between the Western and the Eastern hemispheres also, because it is also along the anti-meridian. It is not straight, but it's rather zigzag, so as to avoid certain countries' boundaries. Because you don't want the situation that in the same country, one part is celebrating 8th of November, other part is experiencing 9th of November. You cannot have that scenario, is it? So that is why basically, in order to avoid the country's borders and respect the country's sovereignty, that is why the line separates them. Okay, so that is why it is zigzag. It is not straight but zigzag to avoid political and country borders and to not cut some countries in half. Otherwise, the same country would have experienced daytime as well as or same country in one portion of it would have experienced one day and the other portion of it would have experienced the previous day or the next day. So that is why it is zigzag. Having said that, here, when we talk about the international date line, from where are you counting GMT plus and GMT minus? Okay. GMT plus and GMT minus, they are basically calculated from the region of GMT itself. The Greenwich Mean Time is referred to as the standard time. I think that the image is not very clear on your screen. Here, can you see +1, +2, +3, +4, +5, +6, +7, +8, +9, +10, +11? Is that visible to you? Is it visible? Here, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Is it visible? What is that? So the region which experiences sunrise before Greenwich, that is the region which will experience time moving ahead. For example, in India, we have experienced sunrise much earlier than London or Greenwich. So in India, we are already in daytime. They are still at night. right? So that is why these are the regions. Plus the planet rotates from west to east, so to the east of Greenwich, those areas will receive sunrise first. They will have a plus. Those regions on the west of GMT, they will experience sunrise later, so minus. Okay, that is how. Okay. Okay, anybody who has seen the animations of these videos which are available on our YouTube channel or even in the tablet lecture? No? Kindly take a look. Kindly take a look. It will be much more comprehensive in the sense that if you are looking for animations, we have provided that animations. It is available on our YouTube channel also. It is available on the tablet lectures also. So take a look at either of them. It will be self-explaining in that aspect also. Please provide link and path. Okay. Should I also play the video out? See, I understand that you guys browse the internet for almost throughout the day. So I don't think that this will be too much of a hard work for you to think about the link and the pathway. Okay, please don't get into the habit of, at least not in my class. If it works in other subjects, I don't know. But at least in my class, I never believe in that kind of a spoon feeding. That way, give me the link, I will see it, and I will do some kind of an obligation to you. You are not obliging me by watching the link. If you want to help yourself, it is present in the tablet lectures, in the basics also, in the YouTube under the knowledge series also, that their animations you can watch. Okay. Now, here, I hope we are clear with the directions. North, south, east, west. I hope we are clear with the directions. And I also hope we are aware that direction is always relative. For example, India is to the west of China, but India is to the east of Pakistan, right? So if we say that India is to the east, it does not mean India is to the east of every place in the world, right? For United States, we might be to the east, but for China, we are to the west. Similarly, direction is always keeping in mind the relative position of what we are talking about. So when we talk about the IDL, the international date line, the international date line basically will also have the presence of, so here the western portion of west, to the west of IDL and to the east of IDL. What happens when you cross the IDL? This is your IDL. So on the west of IDL, you have the region such as Japan. On the east of IDL, you have the region such as US. Okay. So when you talk about, let's suppose, Japan or US, as of now, Japan would be experiencing 9th of November, just like we all are. So in Japan, it is 9th of November. In US, it is what? Still 8th of November. They are still in the previous day. Let's suppose I have my birthday on 8th of November. Let's suppose. Now, I celebrated my birthday in Japan, and then I caught a flight and I moved to US. When I reach US, I find out that they are still celebrating 8th of November. So I get to relive my birthday ever again, isn't it? So here, what am I doing is, basically, as I'm moving from west to east across the IDL, I am in a way reliving that day again. So I am gaining a day in my life. Okay. I am going to gain a day in my life. So as you move from west to east across IDL, gain a day. And gaining a day means I get to relive that day again. But then overall, how will I adjust my watch? My watch, when I was taking off in the flight, my watch had indicated 9th of November. But when I landed, the region is celebrating 8th of November. So how will I adjust my clock and the watches? Eventually, I will subtract a day here. From 9th of November, I will take it to 8th of November, isn't it? So overall, you subtract a day. Then, what if I move from east to west? Now, let's suppose any of your, if you have taken off or if you have sat in a flight on 8th of November in US, you cross the IDL within a few minutes and hours. When you reach Japan, you find out that they are already celebrating 9th of November. You took off from 8th of November and within a few hours you reach a place where they are celebrating 9th of November. So in a way, you have lost a day in your life. It is like a fast forward, you have lost a day in your life, isn't it? So how will you adjust your watches in that case? You will need to add a day. From 8th, you will need to adjust your watch to 9th. So when you move from east to west, lose a day and overall in your watches, you add a day. So that is how you experience the change when you cross the IDL from one portion of IDL east to west or west to east. This is your international date line. This is the region of your international date line, right? It is quite zigzag. So when you cross the IDL from west to east, you basically gain a day in your life. West to east of ideal, this is your west of ideal, this is your east of ideal. When you cross from west to east, you basically gain a day and you subtract a day from your watches or calendars. And then when you move from east to west, you lose a day or you add a day in your watches or calendars. That is how. Now, obviously, there was a question. That is why I basically addressed that beforehand. If US lies on the west, how can it be in the east? Very, very beautiful question. US lies in the west of what? US lies in the west of what? In the west of everything in the world, US lies in the west of it? Or is it certain point from where US lies in the west? That is why I told you India ideally lies in the east. But when you compare it to China, India lies in the east or west? India lies to the west. When you consider the direction with the international date line in reference, if international date line is in reference, US will be in the east or west. Is the direction always fixed? When you think about, let's suppose UK or Britain, Britain is to the east or west? If I ask this question, let me know, Payal. Britain is to the east or west? So you will obviously have a follow through. East or west of what? Are we considering India as a reference point? Then it is to the west. If we are considering US as a reference point, UK is to the east. So similarly, when you designate a direction, you always have a reference point in mind, isn't it? So if you consider IDL as a reference point or a reference line, then US lies to the east of it. If you consider GMT as the reference line, then US lies to the west of it. Is that clear? Right? Good. International date line moves between Russia and Alaska. Yes. Okay. So now we initiate the discussion about geography. So before you start scratching your head that what we have been doing till now we have just been scratching the surface, trying to revise what you have studied in your childhood days. So now we initiate the discussion for the portion of geography. Anti-meridian and ideal, they are not the same line. Ideal passes through the region around anti-meridian, but it is zigzag. It is not straight. Okay. Now, Here, when we talk about Earth as a planet, now Earth has got various different systems included in it. Now, according to the various different processes, life cycles, etc., which operate on the planet majorly is divided into 5 systems. One is lithosphere. Lithosphere is a land that we stand upon, the land that we all see. That is the mountains, the valleys, everything that we see. That is lithosphere. Then all the water in the world, that is referred to as hydrosphere. All the water across the world, oceans, seas, everything is included in hydrosphere. Then all the air surrounding the planet, that is atmosphere. The blanket of air surrounding the planet, that is your atmosphere. Then all the living species on the planet, all of them, plants, animals, microbes, giants, everything included, they are a part of the living system of the planet, that is the biosphere. But you have another system also, that is the frozen regions of the world. The North Pole, the South Pole, the region around Arctic, for example, frozen. Antarctica, permanently frozen. Himalayas, after or beyond a certain height, permanently frozen. Alps, beyond a certain height, permanently frozen. Rockies, Andes, Atlas, anything that you consider beyond a certain height, permanently frozen. So those permanently frozen areas, they form a part of cryosphere. So these are the systems which shape or influence the occurrence of various different cycles, regenerative seasons, etc., that you experience on the planet Earth. As we move ahead, we will be covering lithosphere primarily. In the portion of geomorphology, we are concerned with lithosphere. Then we will come to the portion of climatology, where we will be covering the portion of atmosphere and some portion of cryosphere as well, in terms of the properties of heating and cooling, that how the temperature across the planet can be influenced by the regions which are permanently frozen. Then you also have hydrosphere. That is something we will be studying under oceanography, about the oceans of the world and the behavior thereby. What was earlier included into the portion of biogeography, that is biosphere, now you will study it under the separate topic and the separate subject of environment and ecology. Now, lithosphere is what we are concerned with as of now. So, when you start with the lithosphere, certain basic geomorphological aspect that you witness in your day-to-day life, right? For example, the image on the left side of your screen here, this one. This is the image of a mountain. In fact, it is the image of the tallest mountain peak across the world, the image of Mount Everest. So, when we say a mountain, what do we mean by a mountain? So, mountains, they are typically those landforms having a significant amount of height, very large height. They will have conical and a distinct peak-like feature. Observe, a peak-like feature, right? Edges will also be present in these areas. So, greater height, conical distinct peak, right? These are the features of the mountain, sharp edges, etc. Now, beyond a particular height, the temperature reduces so significantly that everything or water cannot exist in liquid state. Water will be able to exist only in solid state. Solid state of water is ice and snow. So water will be able to exist only in solid state of ice and snow. But beyond a particular height, as you have all of that ice and snow, aided by the influence of gravity, that starts moving ever so slowly down the slopes. The ice and the snow, they start rolling down the slope very, very slowly so. but they do move. These moving masses of ice and snow down from the mountains or down from the peaks, they are referred to as glaciers. Moving mass of ice. They are known as glaciers. We will study more about glaciers also. I will give you the examples of glaciers also as we move ahead. Then you will find certain features like hills. Now, hills, you will find that they are different from the mountains. If you compare the hills from the mountains, they are different. The height is very less, isn't it? The peak is not conical. You will have rounded peaks in existence. So when you talk about hills, lesser height, rounded tops, mostly under vegetation. So you would have heard about, for example, Himalayas, you'll find mountains. Nilgiris, you will find hills, isn't it? Anamalai Hills, Palni Hills, Shevroi Jawadi Hills, Garjat Hills, Ramgarh Hills, Kaimur Hills, right? You will never hear about mountains in these areas. Okay. Then what you observe here is a kind of a plateau. What is a plateau? Plateaus, they are flat tableland-like structure. Plateau, these are basically going to have a shape like this. Mostly because of volcanic origin, right? Volcanic origin, you have volcanoes which erupt, which would have erupted long time back, hundreds and thousands of years ago, and all the molten materials would have been spread, they would have solidified. So a flat tableland-like structure, tableland-like structure with steeper edges. Not very steep, but significantly having an edge there also. These are your plateaus. Tibetan Plateau, Deccan Plateau, Meghalayan Plateau, Chota Nagpur Plateau, Bastar Plateau, Karnataka Plateau. All these are examples of plateau and tableland-like structure. Okay. Now let us take a question from this area and then we move ahead. So this is a question which appeared in 2019. On 21st of June, the sun does not set below the horizon at the Arctic Circle, does not set below the horizon at Antarctic Circle, shines vertically overhead at noon on equator, shines vertically overhead at the Tropic of Capricorn. Good. Majority of you have given the correct answer. So on 21st of June, it is permanent daylight in the Arctic region and the region of North Pole, because the planet is tilted in such a way that northern hemisphere is towards the sun. So the sun will not set below the horizon at the Arctic Circle. It will be permanent day. Okay. 21st June is basically summer solstice. Perfect. So with that, we'll do one thing. We'll take a break. And when we come back from the break, we will come about, or we'll talk about Earth and its interior, rocks, and we will then sink our teeth deeper into the portion of geomorphology. So we take a break. I think a 10 minutes break would suffice, right? 15 minutes break. Why 15 minutes? Okay, take 15 minutes break. Initial classes, I don't want to overburden you. So take 15 minutes. Why C is not the answer? Because the sun will be vertically above the equator at noon during the conditions of equinox. That is why. Shyam, can we place solar panels to generate electricity at South and North Pole when it receives daylight for several months? No, because there you have significant amount of snowstorm and ice storm, which does continue to happen even during those months. So solar panels won't be the idea. But having said that, solar energy is one of the energy generated. So but then that requires frequent cleaning of the solar panels with very short time interval. Okay, in a semicircle, Shalu. Okay, let's take a break and let's be back. A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. So now we come to the first module of geomorphology. Geomorphology basically is about the study of the land surfaces and the changes which keep on happening on the land surfaces. Why do these changes happen? Why is it that the earthquakes occur? Why is it that the volcanic eruptions are experienced? Why is it that certain regions they keep on moving away from each other? You would have heard about theories that Africa as a continent is breaking into two, and over the next few millions of years Africa will be completely broken. Over the next few millions of years, Mediterranean Sea would disappear. So, why do these movements happen? Why do the mountains get created? Why is it that the rivers they do create certain kinds of landforms overall? So that is all that we will study in geomorphology. We start with this module where basically we will be talking about the earth, its interior, the different rock systems, the primary classification of the rock systems, and the plate movements, the origin of oceans and continents. That is something we shall be familiarizing ourselves with. Now, this is a portion which is going to be relevant both for your prelims as well as for your mains examination. And frequently, questions are repeated from this area, so you don't have to worry too much. You will find the same trend of questions, same pattern of question that UPSC repeats year after year in the mains examination, both for general studies, by the way, and even for the optional also. UPSC repeats the similar type of question. So first of all, the regions relevant or the portions relevant for your prelims. Interior of Earth, interior structure of Earth, then the discontinuities, then basics of rocks, then basics of plate tectonics. Plate tectonic theory is something that we are going to study. Okay. Now, after this, in the this portion for the mains examination is also super important. In mains questions, when they are asked from geomorphology, mostly they will be asked from either this area or earthquakes and volcanoes. That is the next module. So here, questions about, even last year you had basics of rocks also asked from here. Then theories, continental drift, seafloor spreading, and also plate tectonics. From these areas, questions are oftentimes asked and framed from. Okay. Now, here, ideally, if you open up the NCRT or any of your reference books, you will find that this area, when you talk about the interior of Earth, so that is the first topic that we shall be covering. When you read any book, they will be going ahead, you will find a pattern. They will tell you that, look, planet Earth is divided into these many internal structures, these many interior layers. This is the name of this layer: crust, mantle, core. This is certain couple of pointers about it, and that is it, right? But many of the, now this is an approach which works as long as up till you are in class 10th or class 8th, where a greater level of understanding is not sought. Now, when you are preparing for the civil services, you need to have an actual idea about the interior structure of planet Earth and how that interior has evolved. What are the evidences, or what is the process that has elapsed during the entire period of evolution of planet Earth? Planet Earth that we see today has not always been like this. Planet Earth has come into existence roughly estimated to be around 4.5 billion years ago. 4.5 billion years ago. Let that sink in, how long that time period is. So that is when the planet has come into existence. At that point of time, the planet was nothing but hot ball of molten mass. Everything was molten. Now, since that point of time, where everything was in a molten state, molten as in liquefied state because of higher temperature, from that time to present day, where we call the planet as a blue planet, planet Earth has traversed a long distance. Planet Earth has basically covered a journey of evolution. So, what we will be doing is, first of all, we shall be making ourselves familiar with the evolution of planet Earth. Very briefly, so, we shall be talking about the various stages in the evolution of planet Earth. How is it that the planet Earth has come into existence? And how that process of formation has led to the different properties that we observe. Once we understand the formation, then automatically the aspect about the internal structure, the interior structure, and the following on processes about, let's suppose, volcanic eruptions that we will study later on, plate tectonics that we will study tomorrow, all of that comes easier. So that is why we will be approaching, first of all, with the genesis, the origin, or the formation of planet Earth. Now, here, planet Earth basically did come into existence around 4.5 billion years back, as we have talked about. So let's talk about the formation of Earth. Now, how did it come into existence? What was the process involved? By the way, the theory which basically is used to explain the process of formation, various different theories have been postulated by many numerous number of scientists over the ages. Not many of them have stood the test of time. Many of them have basically faltered and they are incorrect. But the theory which basically does make sense is the accretion theory. What is accretion, by the way? Accretion refers to accumulation, isn't it? I hope you are aware. Accretion refers to when things get together. That is, when materials they accumulate. That is what is referred by that. Now, let me take you back around 4.5 billion years ago. What was the situation? What was the condition? You had the sun, which had come into existence, but not for a long period of time. And the solar system was very unstable. Solar system was not at all resembling the solar system around the sun. You had millions and billions and trillions of small particles, the dust particles, which would be moving around in a kind of a circular or an orbital manner around the sun, aided by the sun's gravitational pull. They would be aided by the solar gravitational pull and all these dust particles. So I am going to represent only the dust particles which would be present around the region where you find planet Earth as of now. So just like that, you had millions and trillions of these dust particles moving around the sun. Why were they moving around the sun? Why were they not stable in one place? Well, aided by the gravitational pull of the sun, that brought about a kind of a movement. Many of these particles were swept by the solar gravitational pull also. Many of the particles which were closer to the sun were immediately consumed by the gravitational pull of the sun, right? But the particles far away, they did not exactly fall on the sun, but they kept on moving around. All these dust particles came into existence with the cooling down of the solar system after the formation of the sun. The process of formation of the sun, basically, when you had the gases of hydrogen, helium, that led to the formation of the sun. And basically, as the temperature cooled down in the externalities, you had molecules getting created, molecules forming certain at a certain particular state of matter, solid, gases, etc. And that is how all these dust particles consisting of various different compounds, they came into existence. Now, before we move ahead, when two particles they collide, right, certain basics we shall cover. When two particles collide, and listen to this very carefully. When two particles they collide, let's suppose, what will happen? Now, those of you who have read physics, rotational, etc., momentum, conservation of momentum, etc., you'd be aware that there are different forms of collision, etc. The conservation of momentum also happens, but let's not expose ourselves to that many technical terminology. Just think about it from the layman's perspective. What does your common logic tell you? If two objects are coming towards each other and they collide, chances are they will be broken into many small parts and they will be thrown and dissipated away from each other. Or if suppose a particle is moving in this direction and there's another object coming from behind and hitting it, then what will happen? Chances are that the force of impact will carry the other object along with it, and the impact in itself will produce that much heat where the materials they get joined together. Regardless of whatever type of a collision it happens, whenever there is a collision, I think we all can agree on the fact that whenever there is a collision, there will be substantial amount of heat which will be produced. Substantial amount of heat, which that heat, materials, they weld together. The materials, they join together. Right? And another thing that you should be aware of is the fact that the gravitational force is responsible to or is proportional to mass. Greater the mass, greater is the force of gravitation. I hope we are all comfortable with these two pointers. Now, as these dust particles were moving around the sun, around 5 billion years, 4.5 to 5 billion years back, now many of them, basically, it would not be the case that few of them are moving like this, other is moving like this. It would not be a typical traffic situation that we observe in our country. No, you had all of them moving in a similar direction. So collisions started happening because you had so many particles in the same place. Collisions would happen. Now, whenever collisions would happen, heat would be produced, and due to that heat, the materials which would be colliding would be sticking together. And as a consequence of that, the size of the material would increase. Think about it. Earlier, you had two small particles moving. Now you have one larger particle which is moving. One larger particle means greater the mass, greater is the force of gravitation. Means it will attract other particles to it as well. Means there will be greater number of collision. So this was a kind of a cycle, a cyclical process. And what was the cyclical process? Collision would lead to rise in temperature. Rise in temperature would lead to materials joining together. See, the annotations of the PPT will be available to you. So as of now, I want you to focus all your attention in understanding the concept. Once you understand the concept, you will never forget it. Okay? So pay all your attention in understanding. Materials joining together means what? Increase in mass. In mass. of the particles when there would be increase in mass. That means increased gravity. Good. Increased gravity means more collisions. More collisions would mean further rise in temperature. And at the end point, at the end process, you would come across larger particles in existence, right? Many of these hundreds, thousands, millions, billions, trillions of these collisions would have taken place continuously almost. So the size of the particle would increase. And in this process, you had creation of large mass objects, which are referred to as the building blocks of the planets. And they are referred to as planetesimals. So, due to this process, in the eventuality of this process, you had creation of large planetesimals. What are planetesimals? Building blocks of planets. Okay. Now, these planetesimals were quite significantly larger to the size of the asteroids that you see or observe nowadays, many of them to that size, and few of them even larger than that. Now, many of these planetesimals also underwent collision around a particular region, for example, in the orbit that you see where the Earth is moving. So, whichever planetesimals were in existence at that point of time, they underwent collision eventually. Because please understand, suppose you have one planetesimal, imagine, and here, let's suppose this is the shape of a planetesimal which is moving around the sun. It is hit by another large planetesimal. Now, if this is the planetesimal which is moving around, another one hits it, it develops a kind of a rotational motion, and that rotational motion is conserved. Conservation of angular momentum, basically, it will perpetually continue to rotate, and at the same time its speed would also increase. With every collision, the speed would also eventually increase. Now, multiple of these planetesimals, they actually collided to form planet Earth. But then, with every collision, the temperature would increase. And in the early stage, the solar system was so unstable. You had so many particles which would be moving around, and so many particles in the orbits of the planets, that there would be hundreds and thousands of collisions almost on a daily basis. So, at the end point of it, these planetesimals collided to form proto-Earth, the earliest form of Earth, that is proto-Earth as it is referred to. But this was in a molten state. This would exist in a molten state. Why? Because of very high temperature which would be experienced due to multiple collisions. So what you had was basically a large molten ball of mass. Molten Earth. When we study climatology, we will study that at this point of time, even the atmosphere was very different. Atmosphere at this point of time consisted of only hydrogen and helium, not the gases that we see today, but only hydrogen and helium was present. Now everything was liquid here, and liquid including multiple different types of elements consisting of different types of compounds altogether. isn't it? Now, here, imagine a kind of an experiment, if you can, where if you have, let's suppose, a container. In that container, you put in honey, then you put in water, and you put in oil. Now, all of them, honey, water, and oil, they will have different property, different density, different mass. So, will they form a unique homogeneous liquid mixture? No. They will basically separate themselves. Oil will start floating on top, honey will settle at the bottom, right? They will separate themselves based upon mass. Similarly, when the earth was present in a molten state, the heaviest elements which were present, they started settling down to the bottom. At this level, heaviest elements settle down at the bottom, and layers started to develop. Based upon the difference in density, mass, weightage, etc., layers started to develop. Now, after this, by the way, when we say heaviest elements, at this point of time, the heaviest elements which were present were basically iron and nickel. So, here, at this point of time, heaviest elements which were present were iron and nickel. Okay. So, they started settling down. By the way, many of the times when I say bottom of earth, many of the candidates, they get confused. They say that the bottom of earth will be here. No. I hope we are all aware that from all directions, when you consider the bottom is nothing but at the center of the planet. Right? That is the bottom. So it is at this stage when you had the core of the planet getting established. Even today, you will find that the core is dominated with the presence of iron and nickel. Iron and nickel are the dominant elements present in the region of the core even today, since that time of evolution itself. Now, the planet started to cool down, but on a daily basis, it was flooded with a lot of such collisions into the molten material. The lightest elements obviously did go to the top, and the densest elements, they did come slowly at the lower portion. While this process was happening, as I told you, the solar system was not stable. You had many objects flying around, moving around. And at this point of time, roughly 4.5 billion years ago, a massive collision unfolded. A collision which was so massive because a large object, almost to the size of Mars, that started coming to the planet Earth, and planet Earth underwent one of its largest collisions till date. So you had basically planet Earth, and you had another large object to the size of Mars almost, which significantly came with a speed, and it simply collided with planet Earth. Planet Earth was still molten, but then obviously it had started developing layers, stratification had started to happen. So what would happen? Imagine you have a liquid material, and on that another object comes and collides. So a lot of that liquid will be sprayed over, isn't it? A lot of that liquid will be separated and sprayed over, splashed over. And because it is happening at the level of the planets, it is not a small stone that you are throwing in water. You will have large mass which will be splashed. Now, this flying planetary body, which was coming and colliding with the planet Earth, this was named as Theia, Mars-sized object colliding with liquid or molten Earth. As a consequence of it, you had large materials which were splashed. Large number of materials which were splashed away. Molten materials, obviously, many of them forming small chunks also. Right. Eventually, all these materials, basically, they were escaping away from planet Earth. Because of the collision, materials were escaping away from planet Earth. But they were held by the Earth's gravitational pull of attraction. The Earth's gravitational pull of attraction did not let them go away. So as a result of that, all these objects, they came together, held by the Earth's gravitational pull, and started moving around the planet Earth, held by the planet's gravitation. And that object we see even today, and we call it the moon. So this is how the moon came into existence. So basically, when you had Theia which collided with molten Earth, large mass separated, but was held by Earth's gravitational pull and became the moon. So that is why moon even today consists of many of the materials which you find on planet Earth. But here, mind you, all the upper portions of planet Earth were carried away, not the densest of the materials. That is why even today, also because of the size, you will find that moon is still 1/6 the mass of planet Earth. So the gravitational pull of moon is also very, very less. That is why you will find those famous videos where the astronomers basically, or the astronauts basically, they end up jumping on the moon. And the popular misconception which is prevalent almost across all the candidates, they will ask a question, why moon has got no gravity? They will always ask the question that moon has got no gravity. It is not the case it has got no gravity. Moon has got a gravitational pull. Any object which has a mass will have a gravitational pull. Just that its gravitational pull is not as strong as you observe across planet Earth. Why? Because the mass is less. Now, this process of evolution of planet, or this theory, which would explain the evolution of moon or the formation of moon, this is what is referred to as the giant impact hypothesis. Because as per this theory, moon has been created because of a giant impact. So this is referred to as giant impact hypothesis. Many portions of Theia eventually they also solidified in the interior of Earth. In fact, recent findings, very recent research paper has been published about this, about the giant impact, and it has suggested that many portions of Theia have solidified under the region of Africa, present day position of Africa, and under the region of Pacific Ocean, as the materials of Theia would get distributed in the interior of molten Earth. Because Earth was liquid, Theia had broken down due to the collision. So these materials got displaced and they solidified in the interior of planet Earth. So you will still find evidences of remnants of Theia in the interior, and the evidences of the impact of collision in the region of the moon. It was during the Apollo missions to the moon that we got to know when certain rocks were brought back. That is when this giant impact hypothesis was actually finalized. But nonetheless, here the moon or the planet Earth was still in a liquid state. It was still in a molten state. And it was still solidifying. Now, this process of solidification overall, if I have to talk about here. So, from the giant impact hypothesis, we first then come to how the solidification would be initiated. Now, solidification means what? Cooling down. Solidification means cooling down, isn't it? It loses temperature. Now, it started losing temperature, but the temperature is lost ideally from the surface. It is not the interior which will start losing temperature. The temperature is lost from the surface. And the lightest materials were present on the surface. So surface started solidifying. And it started solidifying in a very weaker structure, not as strong a surface as we see today, but weaker structure. In the interior, everything was still molten. Now, when you have molten materials and you had the surface which had just started solidifying, at that point of time, basically, you can imagine it like a milk container, or when you basically pour milk in a utensil and then you heat it up. Now, what do you observe? After some time, a thin film develops on top of the milk. The lower portion is still very hot, but maybe the top portion starts to have that solid structure of almost, right? But if the milk starts bubbling again, that is broken. That solid structure of the on top is broken very easily. Something very similar happened here also. As the surface started cooling down, in the meanwhile, you had a lot of gases trapped in the interior of the planet. Now, here immediately a question will come to your mind. How come gases were present in the interior? Gases are present in the atmosphere. So, what is he saying about that gases were present in the interior? So, understand this. When you have various different compounds, such as, let's suppose, iron oxide, Fe2O3, Fe3O4, Al2O3, let's suppose, SiO2, all these are compounds. All these exist in solid state. But when you melt them, when you increase the temperature, here iron will go into the molten state. But what about oxygen? Oxygen will enter into gaseous state when you heat it up. Here, Al2O3. When you melt it down, aluminium will go into molten state, liquid state. But what about oxygen? Gaseous state. So just like that, you had many gases trapped in the interior. So in this stage, outer portion started solidifying. With lot of gases trapped in the interior. I have some very beautiful questions coming along the way. I will address the questions at a later point of time, but I have questions like, is that Theia collision which was there when the dinosaurs died? And another that is it due to the Theia collision that you have the formation of the deepest trench, Mariana Trench in Pacific Ocean? For all those, let me tell you, when this collision happened, it was around 4.5 billion years ago. When is it that life evolved on planet Earth? Around 3 billion years ago. When is it that the modern life that we know of, that came into existence? Around roughly around 600 million years back. So this happened when there was no water on planet surface. This happened when everything was, life started 3 million years back? No. Dinosaurs went extinct 65 million years ago. Life started on planet Earth around 3 billion years back. So at this stage, at this point of time, you had very high temperature. Everything was in a molten state. No water, no land, nothing, everything in a molten state. Okay, it is at this point of time when the exterior started to solidify. Now, when the exterior starts to solidify, basically, depending upon the internal structure also, it started developing some crumbs, some basic wrinkles of sort, if you can think about it. Certain areas they got uplifted, certain areas they had depression, because as things they will solidify, they basically reduce in slight amount of volume and they start developing creases, crevices, etc. In the meanwhile, all the gases which were trapped in the interior, all these gases they wanted to basically escape. And when the gases which are present in the interior, when they want to escape, they will bring the molten materials along with it, isn't it? So that is what brought about the next phase in the evolution of planet, that is phase of degasification. The phase of degasification. Now, degasification means what? Exit of gases, isn't it? This means exit of gases. So basically, you had a phase where all these gases they started to emerge out. They started to break through the surface because the surface was still solidifying. It was not as hard. It was very easy to break the surface. And across the planet Earth, you came across a situation where across the planet Earth, you had hundreds and millions of volcanic eruption happening on a daily basis. All across the planet Earth, you had nothing but volcanic eruptions happening on a daily basis. And this continued for many thousands of years. Many, many thousands of years, this phase of degasification continued. Okay, you had various eruptions, volcanic eruptions. It is during these volcanic eruptions when gases like ammonia, carbon dioxide, carbon monoxide, sulfur dioxide, oxygen, hydrogen, they started coming up. Now, immediately, oxygen and hydrogen, they combine under higher temperature to form water or water vapor. Water vapor is a gaseous state. H2O in gaseous state is water vapor. So, like that, water vapor started getting created. All this water vapor, as it was expelled outside, immediately it started cooling. Water vapor, when it cools down, it forms clouds. So, like that, you had formation of very, very thick clouds across the entirety of planet Earth. Across the entirety of the planet Earth, you had a thick envelope of clouds which developed because eruption was happening virtually from any side and every side. So, thick development of clouds. Okay. Now, what these clouds did, they basically, again, blocked the sunlight. They blocked the solar rays and eventually provided cooling. So further cooling process was accelerated, and the surface from outside started cooling down, started solidifying, and that cooling process started reaching the inner portions also. But inner portion was still very hot because of the very high temperature that it inherited right since the time of formation. Now, all these clouds, eventually, as the temperature started reducing, all these clouds, they brought rainfall. And then came the phase of continuous or torrential rainfall. Phase of continuous and torrential rains. These clouds, by the way, they came into existence as gases such as oxygen. So various different gases were released: NH3, that is ammonia, CO2, SO2, H2, O2. So all these gases, so clouds which were created were of H2O. Okay. So then came the phase of continuous and torrential. Torrential means something which happens in a continuous manner, continued manner. So then it rained, and it rained in a phase that planet had never witnessed before, and still today we don't experience that rain, because it rained continuously for almost 10,000 years. Think about it. A continuous rainfall for almost 7,000 to 10,000 years. If it rains for a continuity of 2 days, your region gets flooded. If it rains for 4 to 5 days, it is a kind of a cataclysmic event. Imagine a rainfall which continued to happen for 10,000 years and more. That is what is said to have filled all the low-lying areas with water. And that is how 10,000 years of rainfall created that blue planet. And that is how water is said to have come across the planet Earth. Now, eventually, as this basic cooling down happened and water came into existence, here continued to rain for 7,000 to 10,000 years. Again, I will reiterate, as the process of cooling down was happening, and listen to this very carefully before your fingers start typing the next question that you have. So, as this cooling down was happening, the surface was cooling down, but the interior portion was still molten. And in the interior portion, you had a lot of gases which were also trapped. Why gases were trapped? Because any of the solid particle that you consider, any of the solid compound that you consider, CaCO3, anything like that, it will have the gaseous component on it. That is, if you melt it, if you melt Fe2O3, oxygen will be the gas. So the gases were trapped in the interior along with the molten portions. Now those gases along with the molten portions, they tried to come to the surface, because gases, they are so light, they always try to rise up, they always try to come to the surface, even today. So that is why all the gases which were trapped, they started rising up. They brought molten materials along with it. The planet experienced the phase of degasification, when you had gases such as ammonia, carbon dioxide, oxygen, hydrogen, etc. They started coming into the atmosphere. Because the temperature was higher, hydrogen and oxygen, they combined together to form basically the clouds, right? Because clouds are consisted of water vapor. I hope we are aware of that water vapor, when that condenses, that leads to the formation of clouds. The exact formation of clouds and everything we'll study at a later point of time. But that is how the clouds came into existence. These clouds, they blocked the sun rays, and that brought about a further accelerated rate of cooling. Further amount of condensation brought about rainfall. And that rainfall created the blue planet by bringing water into the region of the oceans and the seas. So that is how the planet, over a period of time, from a hot molten material of mass, that basically covered a journey. Now, initially, when you talk about the land, initially you had a situation where everything was nothing but covered underwater. Now, periodic volcanic eruptions in different parts meant that certain areas, basically, they started coming up. Small areas, they started coming up. And that is how small land masses, they came into existence. Small land masses got created. Many of these land masses, they got together to form a small subcontinent or a continental size landmass. So that is the process of entire evolution of planet Earth as well as the formation of moon. Okay? With that knowledge set, now we proceed ahead to understand about the interior of planet Earth. Okay? Sun is solid or gas? Sun is gas. Do you mean all planets have water? No, I'm only talking about the evolution of planet Earth. No, Avnish, everything is fine. Explain last stage again. Last stage as in after the solidification. Basically, the solidification started to happen. See, solidification started to happen from outside. Solidification started to happen from outside, but the internal portion, interior portion was still very hot. And as the solidification happened, the process of solidification was further accelerated by the rainfall which happened for thousands of years, the phase of torrential rainfall. And that is why the outer portion solidified, where the inner portion still continues to remain very hot. And that inner portion is what is said to have the presence of residual heat. Inner portion still remains very hot, and that has given rise, or that is still present today. This is referred to as residual heat. Even today, many of the actions that you see on the planet that happen because of that residual heat. Okay. Shyam, why the surface of the sun not cool down, but the earth, which is 8 minutes away from the sun, is cooling down? My dear friend, first of all, why do you think the sun produces heat? Sun is a source of heat. So if sun is a source of heat, how can you expect the surface of the sun to cool down? Why do you think sun produces heat? Is it because of the sun, heat inside the sun or the sun god, something like that? Sun produces heat because of nuclear fusion, right? Hydrogen combines to form helium, and in that process heat is produced. That is why sun is very hot. That is why even the outer surface of the sun, you will find that even in the region of photosphere, the temperature oftentimes is thousands of degrees Celsius. So why does that portion come into existence? Or the question in itself is invalid. Molten state is liquid. Manish, yes. Inner portion of sun, the entire portion of sun is made out of gaseous state. Sandeep, my dear friend, if you think that the questions that you are pasting is making a particular point, we are able to understand what you are trying to do, please get sincere. Okay. Vishwas, that is what we covered yesterday also. I understand many of you have not gotten the books. Again, I will reiterate, I understand that many of you have not gotten the books till now. So that is why, while we are trying significantly harder to ensure the supply of the books to all of you, in the meanwhile, please understand that your preparation for civil services should not get hampered by that. So, till that point, do take care of the lectures that are available, the recorded lectures which are provided to you, the tablet lectures that are provided to you. Along with that, the additional reading material is provided to you with each of the classes. Just ensure that much. In case you have the NCRTs, which is available for free online for everyone, you can read that as well. So please ensure that your preparation carries on. Any problem that you face, we are there. In the meanwhile, we are working incredibly hard to ensure the supply of the books. Okay, please don't make me repeat this every class. Okay. If the whole Earth was covered in water, then slowly the land masses started emerging. Was it a single mass or different land masses? Different land masses. Small land masses, they started coming up. The question, logical question, how orbit is formed? Basically, the planet moves, or any object moves around a larger object due to the gravitational pull of attraction. Yesterday also we had talked about it, that an object basically ideally wants to fall here, but because of the force or the velocity, it follows a different path. That is why you will find the objects, they take an orbital position. Kindly take a look at the recorded lecture yesterday, Sandeep, it will be clearer. Is there any chance of conversion? Might be, Sham. During degasification, volcanic eruption took place. It means cooling of interior except the core area. Not always. Yes, that meant that significant amount of heat escaped, but even the mantle portion still is much hot as compared to the outer surface. How land masses were created due to volcanic eruptions. How the earth passed through the phase of full of water to ice as it is today. Basically, the cooling process happened. The earth has gone through multiple different phases of various different temperature conditions. This is just about the evolution, what happened around 4 billion years back. Why planets and sun is mostly spherical? Because as they rotate, any object which continues to rotate, generally you will find that it gets spherical, right? Any object which moves in rotational motion always from the time of its formation, just like how you knead the dough in order to make chapatis, etc. When you move them in a rotational motion, what happens? They develop a circular or spherical position, something like that. Okay. But sir, some say that water came through meteor. This is also one of the postulations, one of the theories, but it has not been acceptable because the evidences have not been indicated. Enough evidences is not presented. Okay. And there is a nebula which cloud like lead to the formation of Earth. No, that is incorrect. Why same procedure doesn't happen in other planets like Earth? Almost a similar process happened in the formation of uh, Mars also. Almost a similar process happened in the formation of Venus also. I understand your next question will be that why don't we have life on Mars and Venus? So we don't have the exact idea whether life ever existed on Mars or not. It might have existed. You have many different conditions of temperature, ideal distance from the sun, everything, including the ideal gravitational pull. All of them are responsible for creation of life on planet Earth. Okay. Is this process understood? Of all the doubts that you are having, is this process understood? Or is this process still not understood? How volcanic processes happened, how land comes on the surface, I will come to all of that. We will talk about all of that when we reach there. Is this process understood? In the process that we have discussed till now, is there any doubt? What would have happened if that would have happened? What would have happened if sun would not have been there? What would have happened if Jupiter? Everything we will take care of at some point of time or the later. As of now, the processes that we have talked about, is there any doubt which prevails? What has been taught, is it clear? Good. Right. If you have doubt in that, that is something I'm going to entertain. I'm not going to entertain your possibilities as of now. Right. Okay. So that is basically the entire process of formation. So if you have to think about the entire process of formation, it started with the dust particles coming together, the dust particles colliding, leading to the formation of planetesimals. These planetesimals colliding, leading to the formation of the planets. And there, when you had the molten liquid ball of mass, that is planet Earth, it experienced a giant collision in the form of Theia, which was almost the size of Mars. And that collision led to many materials getting expelled from the planet Earth's surface, leading to the process of formation of moon as well. Now, eventually, the planet started to lose temperature. It started to cool down, but the cooling process started to happen from the outside. As the cooling process was happening from the outside, the surface developed certain wrinkles. Few of the areas were upraised, few of the areas developed a depression. So, these wrinkles and the formation developed. Now, eventually, as the surface was cooling down, inner portion was still very hot. It continues to still remain very hot even today, but the inner portion, which had many of these gases, the gases began to basically escape. Now, as the gases they began to escape, there was a phase of degasification where you had hundreds and millions of volcanic eruption rocking across the entirety of the planet. Now, during the phase of degasification, you had gases like ammonia, carbon dioxide, oxygen, hydrogen, sulfur dioxide, monoxide, all of them released into the atmosphere. Nitrogen that you see in the atmosphere today is basically from the ammonia that was erupted and that was expelled that long time back. But the temperature outside was still hot. In that hotter temperature, hydrogen and oxygen they combined together to bring forward the presence of these clouds. You had various other certain small other gases also which were present in those clouds, but mostly dominated by hydrogen and oxygen. Now these clouds they blocked the sunlight, leading to further cooling, and they brought continuous rainfall for a period of 7,000 to 10,000 years, what is also referred to as the phase of torrential rain. That covered the entire planet in water, and the basic planet was referred to as the blue planet. Now, this basically the entire process was completed around roughly 4 billion years back. So in around 500, around zero point 0.5 billion years or 500 million years is when this entire process got unfolded. It is roughly around 3 to 3.5 billion years back when the genesis of life in the form of microorganisms was observed underwater. You basically had microorganisms which started evolving underwater. Now, in the meanwhile, as the planet then further solidified, then still today, you will find that you have the internal portion of the planet Earth still very hot, and that is referred to as the residual heat or the remnant heat, which has been there since the time of formation. And it is this residual heat which is responsible for the various movement across the land masses, the volcanic eruption, etc. All of that that we see happening on the Earth's surface is driven by this residual heat. We will basically name this residual heat again and again multiple times. Okay, it was basic. Is that understood? Right. Anjali, I couldn't understand the how the moon was formed. Moon was formed. You had molten earth. A giant collision happened. Many materials were expelled. But as the molten materials were expelled, they could not escape the Earth's gravitational pull. They continued to revolve in the Earth's gravitational pull itself, and you had the creation of moon. Chandra Jyoti, it is clear, but in school books I read that planets were formed from sun due to explosion in sun. My dear friend, you need to take care of that school book, whichever school book that was, which tells you that the planets were formed from sun due to explosion in the sun. First of all, you need to be like very certain that nobody in the future generation reads those particular school books. Or in case you have a screenshot, you should raise this matter to the highest levels of office as you can. But on a very serious note, basically, this entire formation, the accretion theory, is the most acceptable theory, most accepted theory about the formation of planet Earth. Okay? It is not, see, what has been written there as the explosion in sun basically is talking about the evolution of sun in itself, how the sun got created. So you had nuclear fusion, etc., that led to significant amount of heat, and the gravitational pull was subtended, and that is how you had the various different materials colliding with each other. So it it basically, in the younger age, it does not want to maybe complicate the concepts too much. But whatever we have read here, that is based upon, backed upon by significant amount of researches. It is not a theory I'm conjuring up out of thin air. It is a theory which is the most accepted one. That is why I'm also telling you that even recently, as late as 15 days back, you had a research paper which was submitted, which talks about the evidence of Thea to be present in the region of mantle underneath Africa and Pacific. So whatever is being talked about in the class, you can always answer that. Okay. Residual heat is the heat which is trapped in the interior of the earth since the time of formation of the planet. That is residual heat. Okay. Is that understood? Good. Now we come to the portion of, in sun it is nuclear fusion, it is not fission. So now we come to the portion of interior of earth. So when we talk about planet earth, basically overall it can be divided into three broader layers: crust, mantle and core. Now oftentimes the analogy which is given is that of a coconut. When you want to think about the structure of planet earth, think about a coconut. Now all of you would have seen the ripened coconut. The outer shell of it is very, very hard. When you break it, you have the inner whitish material, which is solid. If someone asks you what is the state of matter for the whitish material, it is solid. But then that solid can, if you compress it, it can get compressed. If you deform it, it can get deformed. And inside of it all, you have the coconut water, the molten form. Isn't it? Just like that, interior of earth also has a similar property. The outermost surface, that is the crust, is very hard, but it is also the thinnest portion across the entirety of the planet. Then you have the bulky solid middle portion, which is the mantle, which is solid but can change shape and character very easily. And then you have the innermost molten material, that is the core. But even in core, you have a solid state there also. But here the question arises, first of all, before moving into all of that, how do we know about the interior? Basically, radius of planet Earth is around 6370 kilometers. In order to reach the center, you have to dig almost 6300 kilometers, 6400 kilometers. Nobody has done that. The deepest hole that mankind has managed to dig is only around 10 kilometers. So how do we know about the interior? So the knowledge about the interior is based upon the presence of in sources of information. So that knowledge of interior is dependent upon the sources of information. And the sources of information can be classified into direct sources, and also indirect sources. Now, when you talk about the direct sources, these basically are two types. Direct sources of information means directly from that particular process, you get an idea about what is present in the interior of the planet. So direct sources basically volcanic eruption. So whenever you have a volcanic eruption, immediately you will observe geologists, they go to that area and they start picking out the molten materials. They start accumulating the molten materials. I don't know if you have seen those images or those particular events where all those scientists, they get dressed in that or they wear that protective asbestos clad silverish suit, and then they, with a scoop, they basically dig out the molten materials, they put it in glass of, or basically a bucket full of water, and they collect those evidences, because the molten materials, they are coming from somewhere in the interior, and analysis of the particles, that tells them about how these materials or from where these particles are coming. So that is why volcanic eruption is one of the direct sources. Other than that, you basically have also the other sources such as direct sources such as mining and digging. So the deepest mine across the planet overall, now China is digging another deep mine, but across the planet it exists around the region of Kola Peninsula, that is in the northern portion of Eurasian continent. You will observe the presence of Kola Peninsula. There you have a deepest mine which was around 12 kilometers, 10 to 12 kilometers deep, but it was abandoned very quickly because the temperature would be so very high. Many people would die at those particular depths, and people could not function sustainably well. But nonetheless, even those mines and even those basic depths which are dug out, they give you an idea about the temperature range experienced in that region. They also give you an idea about the particle structure and size, how it gets changed, how it gets morphed when you go into that area. So these are your direct sources of information. Then you have indirect sources also. What do we have as indirect sources? So basically, you have one of the most important indirect source which gives us an idea about the interior is the presence of seismic waves. That is energy waves generated during earthquakes. Energy waves generated during earthquakes. Okay. So seismic waves have been one of the significant indirect sources. We will study, when we study the earthquakes, we will study about how the seismic waves, or what are these seismic waves, what do they tell us. But basically, whenever, for example, an earthquake which occurred recently in Nepal, now throughout the body of planet Earth, that would have generated energy waves which would have been detected even in United States, even in the region of Pacific, everywhere. Right. So that is how you get an idea about which region these energy waves have traveled through and what would be the state of matter, the property of matter in that region where the energy waves have traveled through. We'll study more about it when we confront the region of shadow zones and seismic waves. But just to give you an idea that this is an one of those indirect sources of information. Then other than that, what are the other indirect sources? Study of asteroids and meteors. Meteors and meteorites also. Basically, the study of celestial objects, the objects which move around in the solar system, be it comets, asteroids, etc. Why? Recently, you would have seen the Osiris X Rex mission, basically, where the evidences or sample from asteroid was collected and brought back to planet Earth. Now, why these are important are basically because this represents the early solar system, the solar system which would have been in existence around 4.5 billion years back, when you had multiple of these particles colliding to form protoplanets, colliding to form planetesimals. So that solar system, how it would have looked like, what would be the elements that these particles would contain, where they would, or whether they would contain water there itself, or such details are given to us by analyzing these asteroids and meteors. That is why this is again an indirect source of information which tells us about the period of evolution of planet Earth in itself, right? Yes, asteroid from the asteroid Bennu. Now, after this, also magnetic and gravitational anomalies. of planet Earth. So different parts of the planet, they experience different type of magnetic field, right? You have the magnetic north and the south pole, etc., and geomagnetism, which is the magnetic field extended by the Earth's surface. So by studying that also, we get an idea about what might be present in the interior. And similar is the case yesterday. Remember, we had talked about the fact that Earth is a geoid. It is not a perfect sphere. Geoid means what? That it is bulged around the region of equator, flattened around the region of the poles, isn't it? Bulged around the region of equator means what? That the distance from the center to the equator is slightly greater. And flattened around the region of the poles means what? Distance between the center and the top of the pole is slightly lesser. So that means the gravitational pull will not be the same at both of these places. So that these details help us understand about the interior structure much better. So these are your sources of information. Based upon these sources of information, we basically have assimilated our knowledge, and we have, it was in the 1900s when suddenly a lot of these discoveries they started to happen, and it was in the 1900s when eventually that a clearer picture emerged about the internal structure, interior structure, and the processes of planet Earth also. So here, when you take a look at the interior of planet Earth is basically constituted of three major layers, that is the crust, mantle, and the core. Now, as you move into the depth of planet Earth, the temperature continues to increase. That is a property which is referred to as the geothermal gradient. Okay. Now it is not consistent that everywhere as you move deeper, the temperature will increase by the certain degree. Sometimes it can happen that as you move 1 kilometer, the temperature can increase by 5 degrees. In certain areas, it can increase by 25 degrees Celsius. So, but general trend is that as you move into the depth, you will experience a rise in temperature. So that is geothermal gradient. What is rise in temperature as we move into the depth. Okay. Now you have the outer thinnest hard layer, that is crust. The middle portion, bulky portion, that is mantle, which is solid. Mantle is also in solid state, but it is that kind of a solid where if you compress it, it can get compressed. If you deform it, it can get deformed, right? Because of higher temperature there also. And you have the core. This is the entire region of your core. This is your outer core, which is liquid, and the inner core, which is very much solid, which is solid. Now here, the inner core is in solid state. Despite the very high temperature, the inner core continues to remain in the solid state. While the outer core can melt, the inner core will still remain in solid state. Why do you think that is the case? Now, for this, I want you to go back again to something that you would have studied in your class 6 standard in the basic science, the state of matter, where you would have studied solid, liquid, and gases. Now, when you consider the solid, any solid substance, let's suppose, solid substance means all the particles are very close to each other, isn't it? Now, when you have this portion or this matter, when it is supposed to melt, then what will happen? In order to get converted into liquid, the particles will start moving away from each other, isn't it? The particles will start. So if this solid gets converted into liquid, the particles will move away. In general, other than water, always you will find that solid occupies lesser volume. If you melt that solid, it occupies larger volume. I hope all of us are comfortable with that. We know that when you melt some solid, it will occupy a larger space, isn't it? But what if you have a solid, if let's suppose you have a solid and you apply pressure from all sides, in the sense you don't allow it to expand at all. From all sides, you apply the pressure, you don't allow that solid to expand at all. Now, if you heat it up, its temperature will increase. But will it be able to melt? No. Why? Because for solid to melt, it requires a larger volume. Here, the volume cannot increase because of that pressure. So, regardless of the highest temperature that it can gain, it will still remain in a solid state. So, when we talk about the region of inner core, from all sides, so much amount of pressure is exerted that it has got no place to expand. That is why it continues to remain in solid state despite thousands of degrees of temperature. Now, immediately a question might strike few of your mind is that then why is it that the outer core is liquid? If inner core is solid, why is it that the outer core is liquid? Outer core would also experience pressure. Not so much. Because the width of outer core in itself can be thought about few thousands of kilometers. So you can think about it that by the time that you are reaching the region of inner core, the pressure has increased by few thousand kilometers in terms of its width. So that is why inner core remains in solid state while the outer core is in a molten state. So here, basically, due to very high temperature or due to extreme pressure exerted from all sides, it cannot expand and hence continues in a solid state despite the very high temperature. Okay? Yes, good. How does groundwater occur? Groundwater basically is present in the uppermost region of the crust itself. Many of the times when you see groundwater, you think that you are reaching almost the center of the planet. Groundwater is basically when you have the rocks, in those rocks, you have some of those rocks are able to hold water in between. So that is how groundwater accrues between the rocks or accumulates between the rocky layers and multiple different rocky layers because the planet's surface in itself has also evolved over a period of time. You have multiple different types of formations of the rock structure. They get changed from one state to another. So many of them, they trap water in between at a depth of only around few meters from the surface, 100 meters at max. Otherwise, 20-meter, 30-meter, you'll find the presence of groundwater. Okay. Sir, we are assuming initially that inner core is solid, then justifying why it is like that. No, Shalu, actually, what is the situation is you had one of those scientists by the name Lehman, right? Now, Lehman basically, for the first time, while he was observing the seismic waves or earthquake waves, for the first time, he noticed something very peculiar at the region around center. So that is when he arrived at the conclusion, and multiple different earthquakes later, we know for sure that in the center you have something which is very dense solid, which is different from the outer molten core. So that is why we know that the inner core is solid, and we know why it is solid. So it goes the other way around. Okay, right? I hope that is understood. Now, does that mean that outer core can expand and that's why in the liquid state? No, does not mean that. It simply means the outer core experiences lesser pressure as compared to inner core. Because if you think in that criteria that outer core can expand, then that brings a follow-up question. That means the outer core will take in mantle also, everything will be molten again. So it is not the case. It is simply the rise in temperature which creates the molten materials. Okay. Now we come to the portion of the structure of planet Earth. By the way, how many of you are in the habit of reading the PPTs before coming to the class? Any of you? No? Okay. So most of you would be in the habit of getting up in the morning. That in itself I am doing, and then attending the class. What more do you want out of me? Okay. Yeah. So no, not before 6 o'clock, but at least the previous day you can glimpse through or glance through the PPTs once. Nonetheless, those of you who are habituated to such kind of a habit, etc., I would always advise that this particular module, the PPT is given out to you. I would advise you to read it once or glance through it. Many things you won't understand, absolutely acceptable, perfectly acceptable, perfectly understandable. But just glance through the various topics, etc., and then come to the session. Then it will be much more fruitful and productive. Okay. Yes, many of you, I see that you have attended the previous batches also. So for you, it will be a revision. Um, no, Avnish, any of them is sufficient. Now we come to and look at the structure of planet Earth very briefly. So planet Earth overall, you will observe that the outer surface is the thinnermost portion, and that is the tougher or significantly harder also. That is the crust, right? Crust of anything. Even your pizza has crust. Even the cakes have a crust. That is significantly and slightly harder. Then mantle is solid. So crust is solid, mantle is solid. And outer core is liquid, inner core is again solid. But then, when we talk about the region of mantle, if I have to tell you here, see, if you have, this is the region of the crust. Let's suppose the outer surface. The crust is around 30 to 35 kilometers thick. That's it. So this is your portion of crust. Then comes the portion of mantle. Now within the mantle, the topmost, the entire mantle is solid. Okay, the entire mantle is solid. Okay. Now within this mantle, you have a layer near the upper portion of mantle itself, which remains in semi-solid, semi-molten to plasticky state. Semi-solid to semi-molten plasticky state. I'm not saying perfectly solid. I'm not saying perfectly liquid. When you would have melted plastic, for example, plastic rulers, etc., you would have observed it doesn't turn out to be a complete liquid. It turns out to be somewhere in between, some amorphous kind, which doesn't have a flow, but it can be deformed very easily. So semi-solid, semi-liquidy state. Above that, you have the solid portion of upper mantle and you have the crust. So this portion of solid upper mantle plus crust, this is known as lithosphere. Crust plus solid upper mantle. Then here mantle, basically for a thin layer of almost 150 to 200 kilometers, the depth of this portion initiates itself around 200 kilometers from the surface. 200 to 300 kilometers from the surface, you have a layer which is semi-solid, weaker. That is the layer which is referred to as asthenosphere. Asthenosphere. Very good. Asthenosphere is derived from the term astheno, which refers to something which is weak. So that is where the term is derived from. Now, asthenosphere is semi-molten and semi-liquid. Why is it so? Above it, mantle is solid. Below it, mantle is solid. Why is it that asthenosphere is semi-molten? That is because at this particular depth, you find concentration of certain radioactive elements, such as isotopes of potassium and uranium. Now, already because of pressure exerted from above and already the higher temperature which are in existence, this radioactive materials, they undergo nuclear reactions and they produce heat in the process. And it is that heat which starts melting the materials immediately in the vicinity. But that heat is not so much that it will completely melt the materials. That is why those materials, they remain in semi-molten, semi-solid state. So this is because of abundance. When we talk about asthenosphere, semi-solid, semi-molten state. So here, basically, materials like uranium and potassium, it is not plutonium, it is a radioactive isotope of potassium, right? Undergo thermonuclear reactions and produces heat. That heat which is produced partially melts material, creating asthenosphere. Okay, so at that depth of mantle, at a depth of around 160 to 200 kilometers from the surface, you'll find a layer where everything is in semi-molten or a semi-solid state. So that is what you find as asthenosphere. Okay, so that is about the layering of the planet. When we talk about the crust, for example, the crust is basically thinnermost portion. It represents only around 1% of the Earth's mass. Okay, we'll do one thing, we'll take it up from here tomorrow. Even though the structure, the interior we have understood, the written portion of it is something that we will cover tomorrow. And tomorrow we will enter into the portion of continental drift and even plate tectonics. Okay, so that will be all for today's session. And we'll take up a few questions and then we'll end the session. Asthenosphere is that layer in the portion of mantle, that particular layer in the portion of mantle where you have some semi-solid or semi-liquid structure which is present, or the materials are present in semi-solid, semi-liquid kind of state or structure. So that particular material, why it is semi-solid or semi-liquid? Because at that depth you have concentration of radioactive materials such as uranium and radioactive isotopes of potassium. Due to high pressure and temperature, they undergo nuclear reaction which produces heat which partially melts the material around them. Okay. Sandeep, my dear friend, you have the entire day to have fun. So I don't want to be that particular medium. So please don't seek fun out of this particular session only. After this 3.5 hours, you have the entire day to seek as much fun, as many different type of questions that you have put forward. All I ask out of you is pay attention in the class. Today we have seen the type of questions that you are putting through and the kind of comments that you are putting through. Let me make myself absolutely clear. This is not going to be tolerated going ahead, right? If we see that someone is not very sincere and someone is creating a kind of a nuisance, that is not tolerated. At least in my session, I won't tolerate that. You might have certain sessions where that is tolerated. Fair enough. Carry your activities and business there. Okay, but please do get serious. Waking up this early in the morning, my dear friend, if you are waking up this early in the morning and then wasting your time doing this, better to sleep it off and enjoy your life somewhere else, or better study some other subject. Don't waste your time like this. Okay. Answer writing for geography we'll talk about tomorrow. Mantle below astronosphere is again solid, Ziba, correct. Discontinuity we'll talk about tomorrow. We have not covered today. Sujal, 11th and 12th NCRT. Uh, Chandrajyoti, molten plastic. That is the nearest analogy. Shyam, yes, you can. It is very important to make figures in the answers pile. Get the practice of it. Pavani, yes, it is a low velocity zone. Is there water layer also? No. It is present in the portion of the crust in itself. Psyche and geography as an optional is advantageous. It provides you with a kind of an opportunity to score 300 plus, provided you are interested in the subject, provided that subject interests you. So this is much about analysis and understanding of your surrounding. And gravitational anomaly means that in all places you don't have the similar gravitational pull of attraction in the region of the poles. Anomaly means something which behaves out of the ordinary or expected behavior. That is anomaly. Komal, please tell what you answer the question asked why Britain doesn't have sunset. Komal, my dear friend, the question was that it was already said that British Empire never experienced, or the sun never set on the British Empire, not Britain. SEMA PYQs we have done today. Also, we have done PYQ. Tomorrow also we will do PYQ. Ziba, why summer solstice and winter solstice is named according to the northern hemisphere? That is where the land is dominated. That is where majority of the population is living. Yes, you can exit the class. Thank you. My doubt is, Subramania, that according to the theories, Earth is sphere. If we are able to cross core from one side to another, any possibility to come out on another pole? Yes, why not? Asthenosphere is a source of volcano. Dikshit, that is more than sufficient. Vishwas will talk about that as we move ahead with the discussion. As we get more aware about the type of questions in prelims, we will talk about that. Nikhil, try to understand the concept along with the additional reading materials that you read through. Then, after you have understood a concept, during your revision, then make notes. Making notes in the first reading is never justifiable. Okay. Chandrajyoti, roughly around 55 to 60%. Which issues prevent us from digging? Lack of technology. We don't have that much technology, and we are not able to, or beyond a particular point, the temperature is so high that the materials are not able to tolerate. The materials that we know of, they are not able to tolerate that high temperature. uh, Ramavat, do you take offline classes in Hyderabad? Sometimes we do, depending upon the availability and the scheduling. Nikhil, that is going to be a good choice. Can sun become planet like Earth in future? Absolutely not. Absolutely not, Anita. Okay. No, it won't be difficult, Nikhil. Ritika, your questions are not answered. Okay. Payal, your questions are also not answered. Okay. Sheikh, when we come tomorrow, we will talk about the initial portion. We'll talk about the summary of the interior of Earth itself. Dikshit, try to start it at the time of revision. Direction of sunrise and sunset is the same in the northern hemisphere as is in the southern hemisphere. The sun rises in the east, sets in the west. Okay. Yes, Sandeep, I expect better from tomorrow. Please ensure it is better from tomorrow. PYQ poll question we had asked today. Maybe you did not attempt. And Seema, you had one question that PYQ kab karwaoge. I had taken that question. Are we need to read ARM? Yes, you are supposed to read the ARMs. Okay. How to make crisp note of for geography. That is basically, we will come to it. Let us cover some substantial portion. Tomorrow, if possible, I will show you how to make notes also. Don't worry. Okay. When we study about Indian rivers in the time of Indian geography, right now we are studying geomorphology. Then we will cover climatology. Then we will cover oceanography. Then we will cover Indian physiography. Then we will cover drainage systems. Then we will come to Indian rivers. I hope you did not join the session only to study Indian rivers because, yes, Nikhil, it is different. As North Pole and South Pole are flattest, distance from the center of the North, yes. So distance from the center to the north and south is slightly lesser. Distance to the equator is slightly larger. Geomagnetism we'll study tomorrow. I'll let you know how it helps us understand the interior. So that is where we'll end the session here today. SMEs will be here to answer your queries. In case any of your query is not answered, is left unanswered, don't worry, write a mail to us. We'll get in touch. We'll get back to you. See you tomorrow. Take care of yourself. Goodbye. Thank you.